Greetings once more again. Let's go for the last ride right now. Today, and at this time and the point of an hour, I'll be doing the control test for 2018. Control test for 2018. I want us to be ready for our first time control test, which I believe we're gonna write tomorrow. If not tomorrow, it's gonna be on Monday or the next coming week. Let me just say the next coming week. So I want us to practice this question paper. It has some relevant information which you might find helpful in a great way, a huge great way. So please also again don't forget or don't hesitate to ask your question, because we are here for you, we are here to assist you. So please don't forget to ask your question. I'm gonna be trying to be fast as much as I can so that you can have much time to rest. So as you can see that the basic education national senior certificate grade 12 control tests for term 1, it's written sort of like it's Afrikaans, but forgive me for that, but the questions are written in English. So please gonna do all these questions right now. I think 30 minutes will be enough because we now know the concept, so we'll definitely write this thing fast as we can. Don't forget to comment on our comment section so that we can assist each other. Okay, now let's start. Now question number 1. Given the quadratic sequence -4, -15 and -13, now we are given that quadratic sequence. If you need more clarity on number patterns, please do look at our video of number patterns, which is also available on Yebo Tutor. If it's your first time to tune in, don't forget to subscribe, comment, and like on our YouTube channel. Great. Now we are given -4. We are also given -15. We are also given -13. All right. Now let's get the ball rolling. Now, the first question they say that calculate the next 2 terms of the sequence. Calculate the next term of the sequence. Bear in mind, this is a quadratic sequence, and a quadratic sequence, we all know that it has a second constant difference. So now let's check our 1.1.1.1.1. So we're given -4. We also have -15, -30. Now we need the next 2 terms of the sequence. We know that a quadratic sequence has a constant second difference. So what does that mean? That automatically means that we must determine the difference of the term. So -15, we know that d is equal to t2 minus t1. Even if t2 is smaller than t1, it's the principle. We proceed with the principle with what we are supposed to do. So in this instance, we have -15 minus 4. -15 minus 4. So I urge you to also use your calculator so that you can get relevant and be able to be fast as you can. So you use your calculator. So we are saying that -15 minus 4, those are sums which we used to say it's mental work. Okay, so -15 minus 4, we have -11. Then -30 minus 15, we have -15. Now let's determine our constant d. I want to show you a trick which is so essential that we can be able to know that it can help you as much as you can. All right, cool. Now our constant difference here, it's -4, because -15 minus 11 is -4. So now we want to determine this term. You see, we want to determine this term again. So how do we do that? We know that the constant, it's always the same. So now we just have to say, now in order for us to get the first difference, so we say -15 plus -4. Let me just use a different pen now. So we just say -15 plus -4 now. You see, now things are now getting a little bit easy. So we have -15 plus -4. -15 plus -4. Mental work thinking. Then it's -19. Okay. So that's another one. Then now we go -30 plus -19, that's -49. You see, now it's easy. Now things are now getting well. Then again, we need -19. We add it plus -4. That will be -23. Then -49 plus -23, that will be 3 plus 9, 2, which is 72. Yes, that would be negative 72. So our next term which we were asked, it's negative 49 as well as negative 72. So what I first did in this question which we're given here is that I was able to first determine my second constant difference. Then after that, I'm summing it up from the first. So I was able to get the constant difference, which is negative 4. Then after that, I started, okay, thank God. And then I started to do the right thing. Then now we had this first difference. So now I'm summing it up because we know about a quadratic sequence. All the second difference of a quadratic sequence are constant, which means they have the same second constant difference. So we just say negative 15 plus negative 4, then we get our negative 19. Then now again negative 30 plus negative 19, then we get our negative 49, which is term number 1, 2, 3, term number 4. Then now we have our negative 4. Now again we say negative 19 plus our negative 4, then we will get negative 23. Then negative 23, we add it plus 49, then we get negative 72. So don't get hard on yourself. That's how you can get the next two terms of a quadratic pattern. Now, let's move on to the next question which we have here. We have 1.1.1.2. So on our 1.1.2, it's saying that determine the general term of the sequence. This is a quadratic sequence. So automatically what has to ring in your mind is that we know that the quadratic sequence Tn is always equal to an squared plus bn plus c. Now let's determine the value of a. We know that a we calculate by saying 2a is equal to the constant second difference. And our a now will be equal to d. What is our d? Our d is our constant second difference, which is negative 4. So we have our a now in this instance. Small letter a will be equal to negative 4 divided by 2. Then our a will be equivalent to negative 2. Now we need the value of b. We say that on the first video, 3a plus b must be equal to t2 minus t1. Then our a we have calculated initially, which is negative 2. Then now we must be able to determine t2 minus t1. We had it here to be negative 11. Negative 11. Then now we know that this is negative 6 plus b is equal to negative 11. Then we transpose 6 because it's negative. When it cross that, it will be negative. Then negative 11 plus 6, we now have negative 6 minus 11. Please help me. Negative 5. Is it? Yes. 11, yes, to be negative 5. Thank you. Now we need the value of c. Now we know that a plus b plus c is equal to t number 1. So what is our a? Our a is negative 2, our b is negative 5, and what is our c? It's what we are calculating. And what was our term 1? Our term 1 in this instant is negative 4. Our term 1 is negative 4, and we know that negative 2 plus negative 5 is negative 7. Plus c is equal to negative 4. We transpose our 7 as we are grouping our like terms. Then we end up having our c equivalent to 3. Then therefore we can conclude that Tn is equal to, what is our a? Our a, we calculated it and we find it is negative 2n squared. What is our b? Our b, we calculated it and find it's negative 5n, and our c is 3. So this is the general term of our quadratic sequence. So what we did in number 1.1.2 is that we know that this is a quadratic sequence. So since it's a quadratic sequence, we must only just be able to determine the Tn, which is equivalent to an squared plus bn plus c. Then next you must be able to determine your term number. You must be able to determine your value, the value of a, the value of b, and the value of c at the same time. So we did that and we were able to determine the value of a, and we say that 2a is equal to the constant second difference. Then we were able to find our a. Then we used our a in substitution so that you can be able to find the value of b by saying 3a plus b is equal to t2 minus t1. Then we substituted the value of a which you got initially. Then we were able to get it's negative 5. Then now we calculate the value of c by saying a plus b plus c is equal to t1. Then we substitute the value of a we got first time, a value of b. Then after that you make c the subject of formula, and we end up having negative 4 plus 7, that's 3. Then we end up having our Tn, which is equivalent to negative 2n squared minus 5n plus 3. Is there anyone with any question? Is there anyone with any question? Please do ask if you have any question. Please do ask if you have any question. Okay, if you have any question, don't hesitate to ask. Please do ask so that we can assist you. Now, let's move on now to the next question which we have here. Let's move on to the next question which we have. Give me a minute. Right, thank you so much. So I'm sorry for that. I just wanted to fix something. Okay, thank you. Now let's move on. Let's move on. We don't have much time. Now this 1.1.3 is now saying that 1.1.3 is now saying that determine which first term of the sequence to have a number which is less than a number which is less than a number which is less than. That's important that we understand that the value of n which we must calculate must be able to be less than negative 53. So in other words, the value of n which will give us a term, which means we need the value of n which will give us a term which will be less than negative 522. So how do we solve that kind of question which we have here? So you solve it in the same way, because now we know that according to the rules of exponent, according to solving for x which we had earlier on, we know how to determine the inequalities. So basically now we are saying that Tn must be less than negative 522. And what is our Tn? Our Tn is the general equation or general formula which we knew, which we calculated, sorry, in 1.1.2. So we have negative 2n squared minus 5n plus 3. Now they must be less than negative 522. Then now we transpose negative 5n plus 3 plus 522 is less than 0. Then now we have negative 2n squared minus 5n plus 525 less than 0. Then according to the rules of inequalities, now let's determine our critical values. So in other words, now we are equating the equation to be equivalent to 0. Then now we can solve this. You will still have our bus. If this is difficult for you to be able to determine the values, if it's difficult for you to be able to determine the values of the what do you call this, the factors, or the values of the for you to be able to simplify this to get the factors, don't worry, there is always the bus, there's always the quadratic formula. Use the quadratic formula to be able to determine this. Just to recap you, NB, which is not very well, that the quadratic equation said that formula said that x is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. So you can use this formula if you can't find factors, but since you can also be able to find factors, the factors there will be let's be able to find the factors. We must have n minus we must have two brackets equal to 0. The other one must be 2n minus 17. Yes, just check something. Please correct me if I'm wrong. Then the other one must be n minus 15. This one must be plus. But let me just double check that one also on my calculator. Also, please use your calculator so that you can assist each other. Use your calculator also so that you can also be able to assist each other. Which other factors do we have here? Negative. What is our b? Our b is negative 5. Our b is negative 5. Then it's plus. Then it's square root of 5 squared, which is 25. Minus 4. What is our a? Our a is negative 2. What is our c? It's positive 5 to 5. Just did a mistake here. Okay, 5 to 5. just trying to use my calculator, guys. Please hang in there with me, please. Then I have 2 times a, which is negative 2. Okay, sorry, I did the wrong thing in here. It's not 17, it's 35. Sorry about that. Please forgive me about that. So now we know that 2n plus 35 is equal to 0, or n minus 15 is equivalent to 0. Then now, what do we do after that? We know that our n will be equal to negative 35 over 2, or our n is equal to 15. We are not yet done. We are not yet done, because we must be able to bear in mind of the critics here. Now let's understand this. Now let's substitute the value of 15 in this equation. If we can see that this value which we get, is it less than negative 522, then when we substitute the value, we're gonna get the exactly number of negative 5.22. So which number of n will be able to give us a term which is less than? So we know that when we substitute a number greater than 15, we will have 16. Okay, so our n must be 16. Our n must be 16. Substitute your value of 16 in that equation, you get a number which is less than negative 552. So basically, we need a number n which is greater than 16. Any number which is greater than 16 is less than negative 522. That's an obvious case. So always be able to conceptualize the equation which you are given, so that you can have the correct answers in the process. All right, is there anyone with any question? Please, if you have any question, don't hesitate to ask if you have any question, so that we can assist and help you. As well. All right. Okay. Now let's do 1.2. Let's do our 1.2. Let's do our 1.2. Where is 1.2? Yes. Okay. Now on 1.2. Now, the question is saying that the arithmetic series, oh my word, we're given an arithmetic series here. So the arithmetic series is a plus 13 plus b plus 27 plus then plus 139. Then they say prove that a is equal to 6 and b is equal to 20. How can we prove that? What we know is that this is an arithmetic series. So an arithmetic series has the first constant difference. So since it has the first constant difference, we can be able to do that t2 minus t1 is equal to t3 minus t2. And we can also do the same thing and the same thing over and over again, so that we can get a constant difference. So how can we prove that a is equal to 6? So we know that 13 minus a is equivalent to 27 minus b. This can be our equation 1. Our equation 2, we can have that b minus 13 is equivalent to 27 minus b. Then we know that 2b is equal to 40, because we transpose b to this side, then it will be b plus b, it's 2b. Then negative 13 we transpose to that other side, it will be now 27 plus 13, that's 40. Then we divide both sides by 2, then we have our value of b to be equivalent to 20. So now we were able to prove that our value of b is equal to 20. So now let's substitute b equal to 20 into equation 1. So how do we do that? So where we see b in our equation 1, we just put 20. So let's put 20 in that equation. So we're gonna have 13 minus a is equal to 27 minus b. Our b is 20. Then 13 minus 7 is equal to a. So 27 minus 20, it's equivalent to 7. This is the 7. It's positive 7. So it goes that side, it will be negative 7. And negative a, you transpose to that other side, it will be positive a. Then our a now is equal to 6. So now we were able to prove that a is equivalent to 6. Now let's move on to the next one. Now please don't hesitate to ask any question if you can't understand. Okay, now we have 1.2.3. calculate the sum of the term. How do we calculate the sum of this term? How can we calculate 1.2.2, sorry. Determine the number of terms in the series. How many terms are in this series? How many terms? How do we do that? We are given the last number there. Do you see that? We are given the last number 139. So let's determine our Tn. We know that Tn of an arithmetic sequence is equivalent to A plus n minus 1 times D, where A is 6. A is the first term, which is equivalent to 6. And we have n minus 1. And what is our D? Our D now is going to be equal to, come back again here. So let me just do this. So our new sequence is now 6 plus 13 plus 20 plus 27. So 13 minus 6 is 7. 7. So our constant difference is equivalent to 7. So I'm sorry about that. So yes, 7 is equal to 6 plus 7n minus 7. Then therefore we have 7n minus 1. That's our Tn of the equation. But you are not yet done. We have the last term. We want to know how many terms do we have. We were given that Tn is 139. The last term is 139. So we can use that so that we can find the value of n, the value of terms in the sequence. So we know we transpose the 1 to the other side. Then it will be 140. Divide both sides by 7. Then we end up having n equivalent to 20. So how many terms are in this sequence? They are 20. There are 20 terms in this sequence. Now the next question says that calculate the sum of the series. This is a arithmetic, so we know that in order for us to be able to calculate the sum of the series, we use the formula Sn is equal to n over 2. 2a plus n minus 1 times our constant difference. How many terms are in this sequence? There are 20 terms in this sequence. So it's going to have 20 divided by 2. 2, what is our a? Our a is the first term of the sequence, which is equivalent to 6 plus 20 minus 1 times d, which is 7. Then we use our calculator here. We know that this is 10. We know that this is 12 plus 20 minus 1 is 19. 19 times 7. 19 times 7. 19 times 7. 19 times 7. 19 times 7 is 133. So now it's just gonna be 133. 133 plus 12. Then you have 133 plus 12. You know that's 145. 145 times 10 is 1450. So that's our answer. That's the sum of all the terms in the sequence. Now, the next question says that write this in the form of a sigma notation. We know that the sigma notation, it's your numbers. The numbers are starting from positive 6. They are ending at 20. Okay. What is our Tn? Our Tn is 7n minus 1. So this is our sigma notation. The numbers are starting from 6. They are ending to 20. Because the first term of our sequence is 6, and the last the number of terms which we have here is ending to 20. There are 120 terms. Then this is our Tn formula, which is 7n minus 1. The 7n minus 1, we calculated it here, guys. Where is it? Here, we calculated it here. So we already calculated the Tn formula already. So this is our Tn formula. Okay. Anyone with any question? Anyone with any question? All right, no one has a question for me. All right, if no one has a question for me, then now let us go to the next question. Question 2. Let's now look at our question 2. Question 2 is saying that in the diagram below, okay, in the diagram below, this is the diagram which we have, guys. So in the diagram below, I'll just check this here so that we can have the same diagram together. Yes, so it's saying that in the diagram below, PORS is a cyclic quadrilateral with ST, PQRS, okay, PQRS QRS. Okay, that one I see it. It's a quadrilateral with ST as a tangent. Where's ST? Where's ST? Oh, yeah, there is ST where there's an angle 42 degrees. Then also that SR is a chord which is produced at V, and PO and QR. All right. Now our question is as saying now calculate, determine with reason the size of the following angles. What is the size of angle Q? That's easy, guys. They told us P, Q, R, and S is a cyclic quad. So since it is a cyclic quad, what do? We know that about a cyclic quad, opposite angles of a cyclic quad are always supplementary. They are always equal to 180 degrees. So what do we do in this case? So we're just gonna do our Q plus our angle plus our 180 degrees. 180 degrees is got 180 degrees. What's our reason? Opposite angles of a cyclic quad. Opposite angles of a cyclic quad, ne? Then we calculate our Q. It should be 180 degrees minus 108 degrees. Then what is our final answer? Can you assist me to calculate this? 180 minus 108. That's 180 minus 108. That's 72. So our angle Q is 72. Okay. So our angle Q is 72. Now they asked us to calculate the angle R2. Where's R2? Where's R2? Where's R2? R2. Oh, here is our R2. All right. Do you see that PQ is equivalent to QR? So that's an isosceles triangle. So at the isosceles triangle, it's so important that you understand that P1 and R2, they are equivalent to each other. Okay. So let's write that first so that you can solve that question. So you must understand that, okay, let me just say in triangle, PQR, yeah? PQR, so that we can be able to reference everything. So in triangle PQR, we are given that PQ is equivalent to QR, ne? So since they are equivalent to each other, which means P1 is equal to angle P1 is equal to angle R2. Why? What's the reason why they are equal? This is an isosceles triangle because angles opposite equal sides. Okay. These angles are opposite to each other and they have equal sides. All right. Now we know that our Q is 72. So now we can determine the angle R2 by saying that, let me just do this so that we can all see it and understand it. So we can say P1 plus R2 plus our angle Q is equal to 180 degrees. What's the reason? Sum angles of a triangle. Then what is P1? P1 and P2, they are the same. So if this one is X, also this one is also X plus angle Q. What is our angle Q? It's 70. 72 degrees is equal to 180 degrees. So we end up now having 2x is equal to 180 degrees minus 72 degrees. Then 2x is equal to 108 divided by 2. Then our x will be equivalent to 54 degrees. So therefore our angle R2 is equal to 54 degrees. Okay. Our angle R2 is equal to 54 degrees. Is there anyone who has an equation on that question which you are doing right now? Our angle R2 is equal to, the angle R2 is equivalent to, angle R2 is equivalent to, it's equivalent to 54 degrees. Great. Now let's move on to the next question. What is our angle P2? Oh, that's easy already. P2, where is P2? P2 is here. Oh, great. Do we see that ST is a tangent? So since ST is a tangent, now we apply theorem 7, that tan chord theorem, because SR will be the chord, then we touch the chord, then we go, and where it intersects, it's going to go to P2. So basically here we are saying that We are saying that P2, angle P2 is equal to angle S1 is equal to 42 degrees while it's tan chord. Theorem number 7. That's done. That's done. Please make sure that you understand that it's tan chord theorem and it's applied in that sense, in that way. Right. Now, what is our angle R3? Let's look. Where is our R3? Where is R3? R3 is that way. Oh, yes. I can see our R3 here. So what can be our R3, guys? What can be our R3? So there are 3 ways in which you can do this in order for us to determine our R3. Our R3, do you see that R3 is the exterior angle of triangle P, is the exterior angle of triangle PRS. Yeah, it's exterior angle of triangle PRS, and also it can also be an exterior angle of a cyclic quad. Do you see the cyclic quad? It can be an exterior angle of a cyclic quad. So basically, we can also say that it is an exterior angle of a cyclic quad. So our P1, we said our P1 is 54. Our P2, we said our P2 is 42. So we can be able to determine our area there. So let me just use my calculator. Okay, I'll write it down first for you. So we can see that our angle PR3, R3 is yeah, R3, it is P1 plus P2. It is an exterior angle of a cyclic quad. Okay, so we just have to add P1 and P2 so that you can be able to determine R3. So R3 is equal to P1 plus P2, which is equal to, what is P1? P1, we said P1 is 54 plus 42 degrees. Why are we saying that? Because angle R3 is an exterior angle of cyclic quad. It's an exterior angle of a cyclic quadrilateral. So 54 plus 52, please use your calculators as well so that you can assist each other. That's 96 degrees. So that is our angle. Is there anyone with any question based on question number 3 so that we can go to our last question? Oh, our question 4. Is there anyone with any questions so that we can look on our question 4, guys? Okay. Okay, now let's look at our question 4. Now let's look at our question 4 now. All right, question 4. Question 4 now. Let's look at our question 4. Our question 4. Let's look at our question 4, guys. All right, question 4. Are you guys with me? Please say it if you are with me, guys, so that we can assist each other. Ne? Please, I beg you, please. All right, question 4. What is the question 4 saying? Can you read it for me? Question 4. In the diagram below, LK is a, in the diagram below, LK is the diameter of the circle. LK, you can see that it's a diameter, which means angle P, it's 180 degrees. Okay, it's a diameter. RNS or S was supposed to be here, sorry for that. It's a tangent to the circle at N, yes. T is a point on NK. Where is NK? T is a point on NK, okay, you can see that. And TPLKC, yeah, let's just see that as well. Let's just double check that one because I can't see clearly here. And this one, let me just look at this angle which I have here. Okay, cool. Now they're saying that LK is the diameter with the circle centered at P. And RNS is a tangent to the circle at N. T is a point on NK. And TP is perpendicular to KLPLN. Where is PLN? Yes, is X. Now they are saying that determine, giving reason, the size of NI in terms of X. Oh no, the first one is prove that TPLN is a cyclic quad. How can you prove that it's a cyclic quad? How can you prove that that one is a cyclic quad? How can you do that? How can you prove that it's a cyclic quad, guys? How can you prove that it's a cyclic quad? Okay, that one is not hard because we are told that LPK is a diameter. So we can now say that and conclude that angle N2, angle N2, let's just make sure that you see properly. Yes, angle N2 is equal to 90 degrees. Why? The reason is angle in semicircle. Angle in semicircle. Okay. And you already see that 90 degrees. So therefore, N2 plus angle P, that angle P, that LPT, sorry. Angle PT is equal to 90 degrees plus 90 degrees, which is equal to 180 degrees. So now we can now therefore conclude that TPLN is a cyclic quad. Why? Because opposite because opposite angles of a quad are supplementary. Okay. So that's how we can prove that one. Okay, 2 more questions to go, guys. 2 more questions to go, guys. Give the reasons, the size of NI in terms of X. The size of N, the size of N1, size of N1 in terms of X. Give the size of N1 in terms of X. N1 and K, they are equivalent to each other. And K and N290. Oh, great. So now let's do that now, guys. How can we represent N1 in terms of K? So we can represent N1 in terms of K. How, guys, please? How can you present in terms of... Okay, so now we see that all of us, we are seeing that N2, we already know N2, right? So we can just say that angle L plus N2 plus angle K is equal to 180 degrees. So we say sum angles of triangle, the big triangle there, which is triangle NLK. Okay, then it's X plus 90 degrees plus K is equal to 180 degrees. Then we end up having angle K equal to 90 degrees minus X, because we will transpose X to that side and we will transpose, okay, sorry about that. So we say angle L plus angle N2 plus K is equal to 180 degrees, some angles of a triangle NLK. Then now we have to substitute the value of L as X, N2 it's 90 degrees, so X plus 90 degrees plus K is equal to 180 degrees. So now we can therefore have K to be 90 degrees minus X. And we were told that, we were also told that RNS is a tangent. So we can see that N1 here, N1 is equal to K because of the chord NL. So that chord will be subtended to the circumference at angle K. So now we can also see that, yes, now we can now also conclude that say that N1 is equal to angle K is equal to 90 degrees minus X. Why? Because of tan chord theorem. Okay. Because of the tan chord theorem, guys. Because of the tan chord theorem. Now let's move on. We are almost done. We are almost done. We're almost done. Now we have to prove. Our question says that prove that triangle KTP is similar to triangle KLN. So what do we do in that instance? We just say in triangle KTP and triangle KLN. Okay, so what do? We just write first that in the triangles which are supposed to prove in triangle KTP and in triangle KLM. So in triangle KTP, let's look at triangle KTP. We have triangle KTP, okay, and in triangle KLN, we can see that that angle KPT, okay, number one, okay, angle K is equal to angle K. It's common. Angle K is common in both triangles. Number two, we can also see that K P T is equal to angle N2. They are both equal to 90 degrees. Then we can see that, yeah, that's what's important, that we know, that we have to know on that instant, right? So we can see that angle, that one and that one. So therefore we can now conclude that triangle KTP is similar to triangle KLM. What's the reason? Angle. So that's the reason which we are supposed to write that it's angle. That's why it's 3 marks, 1, 2, and 3. Okay, that's why it's 3 marks, because that's one was direct forward, guys. It was just a direct forward question. All right, now we want us to do the last question now. Now, last question is now telling us to prove that KT. Now we are now proving that KT times KN. This is our last question for the day. KT times KN is equivalent to 2KT squared minus 2TP squared, right? So we want to prove that these two are equivalent. So since we now have the similar triangles, triangle KTP and triangle KLM, so what do we do and how can we solve that? So we can say that KT, you can check, we are just checking here now, KT over KL, okay, is equal to KP, our KP over our KM. What is the reason? Similar triangles, right? So now we can see here that KT would then be equal to KL times KP divided by KM, right? Sorry for that. Let me just fix that. It's N, not M here. Did a mistake here. It's N. All right, so we're gonna have KT times KN is equal to KL times KP. But we also know that KL is equal to KP. Let's just double check so that you don't, let's just see that together. Zoom this, we can see that KL is equal to KP is equal to N. Oh, no, please, let me just correct my mistake here. Let me just correct my mistake here. I just did a small mistake. All right, it's KL is equal to 2kp. Yeah, I hope everyone can agree with me on that, because kp and lp, they are equivalent to each other due to that tp, which is perpendicular to kl. So please forgive me for that. So kl is equal to 2kp. Okay, so if it's equal to 2kp, so you can still have kt times kn is equal to 2kp squared. What are we proving again? Let me just double check again. We are proving that, okay, minus tp squared. All right, now are we still together, guys? Are we still together, guys? Are we still together? All right, seems like we're still moving together. So as we are moving together, I want us to also realize the fact that okay, here we are. Now let's just do the final things of the day, guys. Let's do the final things of the day. And now we can also see that kt times kn is equal to 2kp squared, and kp can be equivalent to, by Pythagoras theorem, you can have 2 kt squared minus ktp. Okay, by Pythagoras theorem, so that you can just get that thing in that outcome which you wanted. Then we'll be able to finally have that we having our answer, which is kt times kn is equal to 2kt squared minus 2tp squared. Bear in mind this part, let me just remove it, this part, so that you can remind it yourself. This part is the Pythagoras theorem. So we are using the Pythagoras theorem on that part. Do you have another question again? All right, now they have the last one, prove the theorem. Now that one you do it as your homework. It's part of, we did it on our first tutorial which we had earlier on. Thank you so much, guys, for tuning in. Thank you so much. We trust that you meet again on Friday for chemistry. Please do tune in time, and don't hesitate to ask your question, comment, like, and subscribe on our page. Please make sure that you make use of the group and ask your question as well. Thank you so much, and have a great, awesome night till we meet again.